What happens when you have Jenkins on Jenkins on Jenkins on Jenkins? Today we'll be looking at Stefan's groundbreaking migration journey in 2023 when a company working at called Swissquote operated 50 automated Jenkins instances in Kubernetes, handling around 10,000 builds weekly. Today we'll explore more in depth how Stefan seamlessly transitioned from an old, unmaintained cluster to a new, state-of-the-art Kubernetes setup. We'll uncover the meticulous steps taken to migrate SonarQube and Jenkins controllers, address in-node issues, and optimize their builds. How did he do all this? Navigating these complex migrations with minimal downtime and enhancing CI/CD infrastructure for the future? You'll find out more about that in the episode. But before we get to that, today's sponsor is CloudBees. Kubernetes users benefit from adopting CloudBees CI for streamlined integration, optimized workflows, scalability, and flexibility. With seamless compatibility taking advantage of Kubernetes scalability features, CloudBees CI enhances development processes, creating efficient pipelines, and at the same time, offering advanced features like Pipeline Explorer, high availability, horizontal scaling, and workspace caching. This integration boosts developer productivity, improves team collaboration, and accelerates software delivery cycles, making CloudBees CI a valuable addition to Kubernetes ecosystems. Check out how to use Kubernetes pods as Jenkins agents at the link in the description. First things first, if you got a brand new Kubernetes cluster, which 3 tools are you going to install?
That's a tough question. I had to think about it for a while, and what I would say is I'm a big fan of Argo CD. I heard that answer many times on your podcast as well, but I just gotta agree with this. It's just a great tool for that. The second one is maybe a bit less known. As an ingress controller, I would use Traefik because we've used the basic Nginx ingress in the past, and we weren't too happy about it, and we used Traefik in our homemade cluster that we'll talk about a bit today. We're really super happy about it. It worked really fine. And the third one, it's not exactly a tool that I would install on the cluster for the cluster itself, but at the side, I would use Backstage. It's a really intriguing ecosystem, being able to have all the information about your tools, about what is running on the cluster, links to different observability platforms. It really puts everything together. It's great.
Very good. With that in mind too, regarding observability, very popular topic that's, built out over time. Do you feel that the observability space, when it comes to tooling, it can be overwhelming? Do you feel like it's going through consolidation? Where do you think that's at?
I always feel that there is something missing in observability because there are many different pillars to observability. There is the pure metrics part that works really fine. There is Prometheus around that, Grafana that works great. Then there is the aggregating logs, for example, with an Elk stack that is also fine. Where if things start to get a bit messy is about alerting, about tracking errors, for example, because an error that happens in the logs of your application, it's interesting to have tools like Sentry, for example, which we've experimented with in the past. We're super happy with it, but it's putting everything together, and also the more APM like stacks to have full traces of your application. This is also great, but putting everything together, I really feel today that there is some tools have most of it or half of it, and I don't know yet if it's fully done, if it's a fully finished ecosystem.
Very good. No, fair points. Now, moving on to get to know you a little bit better, can you tell our audience, what you do, where you work?
So I'm Stefan Götz. I started my career as a web developer, so really PHP, HTML, CSS. I actually still am a web developer today. I still do a lot of React, TypeScript. It evolved a bit. Still do also some Java. I started many years ago at Swissquote Bank, which is where I still am today. It's an online bank in Switzerland here, but we also are available in many countries in Europe. And my team and I work on many different things, but we focused in the past on developer tooling a lot. This is today in a sister team, which we'll talk about, and we work a lot on architecture, on providing libraries that enable developers at our company.
And you said, with this web developer background, how did you take your first steps into cloud native?
Huh. Well, many years ago, I had a very small company where I had to be a sysadmin on this. So I had some experience about administering a Linux server. And one day with the team, we decided to have a Jenkins cluster. And uh, well, we decided to install it ourselves, and that's how we jumped into cloud native. It was our first experience with Kubernetes, with containerizing our workload, and that's how we got into it.
Very good. And with that in mind, for someone that's not necessarily from that background, and when you mentioned React and TypeScript, some of these, very large global communities, and then getting to the cloud native space, what were you before? What would you say is the difference, the before and after now that you're in a part of both ecosystems?
Hmm. Well, the thing that I really like, having deployed applications on more classic environment and on Kubernetes now, it's really the configuration files are great, because like YAML or don't like YAML, that's one thing, but the way of being able to really describe your environment, having the Argo CD that is able to do the deployment, it really makes everything smooth, everything streamlined. You can then just scale the number of pods you have. That works great. You can then deploy a new application, deploy 10 times this application, have templates. That works super great. And not having that before was really a different world.
And, it's an ecosystem that moves very, very quickly. As we were speaking previously, just about observability, there's tons of stuff going on. In your particular case, how do you stay, up to date with all the different things that are happening? Do you read blogs? Do you watch videos, listen to podcasts? What works best for you?
Well, to be fair, I'm not that much into the bleeding edge of the Kubernetes ecosystem. My personal ecosystem where I'm a bit too much on the bleeding edge is the JavaScript developer tooling. I know way too much about that ecosystem. On Kubernetes, mainly I listen to my colleagues, because our SRE team who implements our production clusters is very aware of everything that is going on. They will be at KubeCon soon. Also, they went already in the past. And well, they know what they are going to do, and we talk often about what they are going to implement in our clusters, and we just think about ideas on more architecture aspects of that. But I'm not that into the what is going on right now.
Fair enough. That's good. And like you said, you've got your background in the other areas where that's worked, and then like you said, in this case, from coworkers that are working on this in their day to day, it's a great way to find out. If you could go back and give your previous self any career advice, what would it be?
I would say, don't hesitate to say yes to opportunities, even if they sound crazy. If you have the feeling that it can work, just try. It can be fun.
And the thing is, the worst thing that can happen is you say, "All right, now I know that I don't need to do that again," and then you got it out of your system.
Yep.
I like that. All right, so now to jump into the we can say the sort of the crux of the matter, the heart of this conversation. We found an article that you wrote titled "From Zero to 10,000 Jenkins Builds a Week." How did this journey start? Walk me through it.
Yeah. So, well, the story starts about around 2015. So that's quite a while ago. That's when we had 0 builds on Jenkins. It's around when I started at Swissquote. Well, I started a bit before, but we really noticed that teams had their own Jenkins machines that they were running on old developer machines that they had under their desks, and most of the time they were broken, or they did not know exactly how to update it, or the build was just red because it was missing a configuration file somewhere. And yeah, it was also, the machines were not powerful enough, because they were old dev machines. By definition, they were not good enough anymore to be used as machines for development. And they still did their releases on their own machines. And that's, yeah, that was how we noticed that there might be something to do there.
Good. All right. So you identified, the pain point. Then what were the next steps that you took in order to fix it?
Yeah, so that's around the time also where our team was created to really enable teams. Before that, it was a group of people that met regularly, but that's when we really became a team. And one of our first step was say, hey, we can streamline that process. We can create something that will help people have their builds always green and have that as an automated process. And first thing we tried was just to get a bigger and more powerful machine from IT, install Jenkins on it, and have all the builds running on this one. That failed spectacularly, actually, that first idea, because we had most of the same issues that we had before. Not all builds were there. Configuration of each build was missing. We started to need the configuration files on disk of absolutely every single project we had in the company. Luckily, it was way smaller at the time. But really, that did not work. And a colleague in the team said, "Hey, but there is this new thing there is called Kubernetes. Have you heard about it? Because that could be cool. We can put things in a cluster, and well, a cluster is by definition that should work to scale things." And we were curious about it. We looked a bit into it more to see how companies are starting to adopt it. Again, it was 2015, so not a lot of companies were adopting it at the time. And we decided on creating a small MVP of that and having a small cluster. We started with 4 machines, and that each team would get a Jenkins controller that they would have some control on to add their own builds. And each build would run in its own Docker container. That is something that we already had in our development environment. We already used Docker for sandboxes. We'll talk about that a bit later, I think. And for that, we also wanted that the configuration is automated, because if we have, let's say, 1,000 different builds, we want them to automatically be set up with at least a default configuration that works fine in most cases.
Very good. Now, in terms of the architecture of the first MVP, can you walk me through that a little bit more? How does a single Mercurial change travel through the entire pipeline?
Yeah. So yeah, indeed. As you mentioned, we were using Mercurial at the time, so not GitHub, which we adopted way later in the process. So the configuration was that you push a single change, a commit. Well, similar to Git in that sense. You push your change to the central server, and we had a daemon that would then listen to those changes, send the information, the payload of which repository and which commit ID was changed to a central server. A daemon, and this daemon would then look at what maintainer to which team this code push belongs, and then it would contact the right Jenkins controller to then, if it needs to, create the job, and if the job already exists, just maybe update it if needed, or just trigger a build. And well, that's how it would go. And at the end of the build, it would send an email. That's what we used at the time to notify that the build was successful or not.
And was the MVP, in fact, successful?
Yeah, it was a huge success. I think the biggest success we had with this is that it's the full automation. Making the build creation automated was the biggest advantage, because we used metadata on all our repositories to know to which team they belong to. And we use mostly Maven, so POM XMLs. And as soon as we detected to which team it belongs and a POM XML, we created the job for it. So people did not even have to think about it. They just had their CI. And well, people were happy about it. We tweaked a few configurations here and there. And most of our team were on board instantly, but we had around 20 teams around then. All of them in the end had their own Jenkins instance.
But were there any challenges that also came about through the MVP?
Yeah. Something that was a challenge from the very first day and is still a challenge to this day is the assets. So when you have Docker images, when you have npm, Maven libraries or anything, downloading them is quite a challenge. what you can try to do is have caches, but they also have some kind of challenges. For example, writing at the same time the same library from two separate builds can end up pretty badly, or Docker images. They can be quite big, and downloading them can also take a while. So we did implement caches, but it was sometimes we had some challenges, and I had to set up some scripts to just do the cleanup automatically. The other part was the configuration. If you use Jenkins 1 at the time, the configuration was everything in the UI. It was small blocks that you had to move around, say this step is right now, and then if you finish this step, then you go to collect the reports for unit tests, for example. And then you publish that HTML file to be accessible there. And this was very complicated because it was a lot of clicking around. Copying this from one build to another was also quite a challenge. But right after we started, Jenkins 2.0 came along, and it came with a new configuration system, which is a Groovy scripting language, basically, where you can say what you wish to do, and it will do it for you. So, for example, commands like start a node Docker image, or start a command to build a Maven project. So all of this really allowed us to have a very basic script at the beginning to check out the repository, build it, and send an email if it failed. So for that made it really easier to get started.
All right, and then so all this is being done. Then what happens next? You just scale the MVP to 10K builds per week, or what was the next step?
So mostly yes. We did scale that particular architecture to 10,000 builds a week, but we really changed a few things here and there along the way. One thing we did pretty early on is to add SonarQube as a duo to Jenkins. So SonarQube is a code quality solution. We spawn one SonarQube instance per Jenkins controller. So each team had also the rights to configure their SonarQube, what quality gates they want to put in place. So every single time they build something in Jenkins, it will also run the SonarQube checks next to it. And it was really easy because with this new configuration script, configuration language from Jenkins, we also had the ability to have some shared functions, and we had a function to just run the build, and we added the SonarQube steps in there, and most of the teams got it for free from as soon as we rolled it out. So that was a great addition. People really liked it, and we still use that today. There is also a new team that got created as a sister to our own team called Productivity, really more in charge about the pipeline, the developer tooling, and they standardized. They really brought it to the next level, the standard pipeline that we initially built. So they were able to add a lot of automated reports like Allure or tools, or make sure that it works with really all the specific environments from every team. Today, we even have support for mobile application builds. We have some Python as well, and because we really started as only Java, because we are mostly a Java shop. And around 2019, I briefly mentioned it, but we migrated to GitHub Enterprise. That was also quite a challenge because all our ecosystem was running around, using Mercurial to check out repositories and then do the releases and gather information from there. So we really had to make sure that it works with first both ecosystems. And once the migration was done, to shut down the old ecosystem and only work with GitHub Enterprise. And we scaled the number of teams also. That at that time we had like 30 teams. Today we have like we have 50 instances, I think, precisely. And where it became really challenging is to keep all these instances up to date, because teams had the right to add their own plugins. They were able to set their own configuration, and sometimes even configure something that just broke their own instance. So that was a few fun investigations as well.
And with things like that breaking, what did the team do to fix that?
Yeah, so that was probably the biggest project we had after the creation of the cluster itself. It's everything at the time, and I want to stress that we are not sysadmins in the team. We are engineers, and that was really not our first calling, being able to maintain a cluster. We started by having bare bones deployments where we just do a kubectl apply to update things, and doing that for around 20-30 Jenkins controllers became to be very challenging. So that's when we discovered Helm charts, and we decided to move everything to a Helm chart first. So that's when also we decided to have the Jenkins configuration partially immutable. So what's partially immutable? What we did is Jenkins loves Groovy apparently, because they have a configuration system where when Jenkins starts, you can configure it by using Groovy scripts. So we used that to be able to configure everything that is absolutely required to run a build, to, for example, the configuration to Kubernetes to start a pod, or the UI configuration to authenticate users, for example. And we made sure that these pieces were immutable, in the sense that if you restart the container, it just resets it. And for everything else where we wanted people to have access and to tweak things, we would make sure that we don't touch those configurations. So that's what allowed to have still some room for experiments and improvements there, that where teams can test something and then come back to us and say, hey, we tested this and we could add it to the default pipeline. Would be cool for everybody. And also another challenge is that Jenkins's configuration is all on disk, so it's not a database. That is also a pretty big challenge, because when the Docker image starts, it just copies its own plugins to the disk and then starts Jenkins itself. So if you have an old configuration, an old set of plugins, and you start a new version of the image, it will just add the plugins on top. And sometimes by unzipping the whole jars and things, they will conflict with each other. So we made sure that the Docker image itself would bring the latest version of all the plugins we used. So we defined a set of plugins that we saw everybody adopted. And we made sure that when the Jenkins starts, it just has the plugins that it should have, and not some leftovers from a previous version.
So at this point, then it sounds like we have Jenkins on Jenkins. Sounds like only Argo CD would be missing from the mix.
Yeah, so we're building Jenkins on Jenkins at this stage. We automated all that, but we have Argo. That's when our sister team, SRE, was created around that time, or maybe a bit before. They are in charge of all the clusters for production, so not our cluster, which was built with scraps. And they said, hey guys, we built this cluster and we installed Argo to configure it, but we can connect it to your cluster. Do you want it? And we looked at it, say, oh wow, yeah, sure. So on the very first day when we had the ability to do that, we configured the Helm charts we had to be configured from Argo, and from that day we were able at the end of the build to automatically update the Argo definition to deploy the latest Jenkins version.
So at this point, you have several teams, Jenkins that deploy Jenkins, Argo, and on top of that, even more. So the scale at which you operate is so unique that you must have encountered issues that teams don't usually see, right?
Yeah. At this stage, the biggest issue we got is resources in general, and not people. That was fine, but every single resource that you can have in a cluster, every single resource that is finite, we discovered that they have limits at some point. So whether it is network, CPU, I/O, disk space, memory, we just hit all of those at some point and had to figure out a way to get out of it. Most of the time we were pretty naive and thought, well, we'll never reach that limit, that will be fine. And for some of it was pretty easy. For example, the maximum size of a Jenkins log, we got up to a gigabyte for a single build. We limited that to 10 megabytes and told people, well, if you go over that means probably you're logging a bit too much in your build. Kubernetes also is great at managing CPU and memory. That comes out of the box. That is great. But there is one thing that it doesn't do, is then when you start a pod, it just stays up. And for a build, that's maybe not what we wanted. So we created the first Sentinel at the time. We're very creative with names. And that would just shut down the containers after 90 minutes. So you're saying that your build should be 1 hour and 30 minutes maximum. And if you go over that, you have something that time outed, there is waiting on something, or you're just doing something wrong. So, but the biggest thing that we had and scratch our head for years is integration test environments.
And regarding the integration tests, did you run them against a test or staging environment?
Yeah, so for that we got really creative, but because for development we created a system that we call the sandbox. Again, we are super creative with names. And for that was actually a tool that would take your Maven dependencies, and if you have a dependency that looks like a sandbox, or which for us is a development environment, it will add it to a Docker Compose YAML, and it will start it. So each sandbox is tied to a Docker image, and each Docker image then gets a name in the Docker Compose file, and you can address it. So for example, your own application will have a link to a database. So we'll start this database, and if your application has a link to another application, we'll also start this one. But where it really started to beat us is that it works recursively. So if you have an app that starts an app that starts an app and goes all the turtles down to 60 applications, well, it will start the 60 applications. So this was a challenge already on developer machines, because they struggle a lot to have these environments that have a lot of machines, but it's still very easy to add one dependency and it starts the application. So if you have enough CPU, enough RAM, it just works, even though we don't recommend it. And the challenge with that is that it brings really a lot of load on the cluster.
But surely, I mean, with using Kubernetes, distributing this load across the cluster is something that you were able to achieve, or was it something that became even more complicated?
Yes and no. The thing is that Kubernetes is very well aware of everything that is running on it if you start it through Kubernetes. But because we were using Docker Compose, our pods were mounting the Docker sockets on them, and we're starting the containers for the sandbox outside of the main container. So we had some magic tricks to bind the networks together so that it works. But what it meant is that really all the containers that were done for these integration environments were not known to Kubernetes. So what we could get into is that in Kubernetes would say everything is fine, but at the same time it would really struggle. The node would really struggle because there are 200 containers that are running on it right now and hogging all the memory. So this is something that really was a problem. There is also the fact that when you run, for example, Docker build, it will use the Docker socket to start a container, and this is also unknown to Kubernetes. So for all these things, we created a new version of the Sentinel at the time that would try to have a smart way to find which containers were started by which build, and be able to, well, either kill them if they were using way too much memory for what the quota that we would allow them, or also kill them after 90 minutes, because it can happen that we stop a build and that the containers for the integration test for that specific build were still running. So we had sometimes containers that would just stay for days for nothing. And that Sentinel helped us to stabilize the situation a lot, to get that in check so that our users would get their builds running again.
And were there any other takeaways that you got from this situation?
Yeah, that's really when we noticed that we made a big error in the design of this cluster. Being able to use Docker outside of Docker, that's how it's called, was really not something that we anticipated, because we thought it was going to be okay. Again, naive, not sysadmins thinking there. What we thought is, what if we try to run Docker in Docker? That's also a technique that exists. It is technically possible. We tried it, but we got some other challenges there. The thing is that Docker, its file system, is storing the images locally, and it's really made to be run only by one daemon. So that means that when you start a new Docker daemon, you need to start from either a fresh cache or something that is not used by another daemon. So that means you need to download all your images for Docker to be able to run. And this can take a lot of time. If we take again this example of an application with 60 sandboxes, it will have to download the 60 images. And the first time we tried it, we took on purpose one of the biggest ones, and it took 45 minutes just to download the images in the Docker container. That's another of those limits we discovered. The network card was undersized on that machine. We really saw at that moment that this could not scale. It would not be able to do that. We tried to have a runtime that is able to start, instead of starting the sandbox locally using Docker out of Docker, that would use Kubernetes, create a Kubernetes namespace, short-lived one, and start every single pod in there. But that came with a big cost for us, because all the configuration that were created for Docker Compose, for developers to develop locally, and as a ease of use, we would just make that transparent to them on the build environment. And having this second runtime that is slightly different, we never got it really right to be able to move all the things that are possible with Docker Compose, such as mounting files locally. Because config maps, for example, will have a limit of 1 megabyte. And in some cases, we had teams that needed configuration files a bit bigger than that. So this environment never got really big traction, although we really liked the principle and the idea, because it would leverage everything we already know. But it did not work for us.
And, at the beginning of the podcast, we started with a date, we were talking about 2015. At this point in time, how big is the team that's looking after the CI/CD pipeline?
So at this stage of the story, we're around 2023, beginning of 2023. So our own team, who managed at the time the Jenkins infrastructure, just got its 4th member. The productivity team next to us had 4 members, and the SRE team, who would help us a bit on this, were also 4 members. And the most important thing about that year is that we really had a plan to go out of the cluster that we built ourselves, because we saw that it had many limits. We were not able to update it anymore because it was kind of a brittle thing. And we decided also that it would be more suitable that our sister team Productivity would take over the management of the Jenkins controllers themselves, because they already manage the content of the builds. They help the teams using best practices. They already manage the pipeline itself. So it would just make sense that they have the whole ecosystem. And they also manage SonarQube at the time. Still do.
Okay, so with that in mind, the better part of a decade has gone into this in terms of transferring the code, but also the knowledge from one team to another. How did you go about doing that?
Yeah, I don't know how we did that. It was a huge challenge. So the first thing is that if we wanted to go to a proper cluster managed by SRE, we had a few things that were just impossible to run on their cluster. For example, Docker out of Docker, because it's a production grade cluster for a finance company. We can't just have Docker containers running around. So that's what we discussed with them about the challenges that we have, because we still needed to have Docker, for example, just to run Docker build, or to be able to start a test container with a small database or anything. And we talked with them, and they came back with a solution and said, for what your needs are, I think we're going with KubeVirt. So it's a virtualization system that allows to start containers on Kubernetes using the same primitives. So we thought, cool, that's great. And we had some challenges also with still the same as what we had with Docker in Docker, about how we would manage the fact that Docker needs to download all of its images. And that's how they found a neat trick to be able to have an image that would contain all a set of pre-populated Docker images. And they would just, at the start of the container, mount this image by copying it. And we would be able to start from that and run our builds pretty fast. The second thing we had is that we could no longer use local storage, because Jenkins uses local, as I said, Jenkins uses local storage to store its configuration. And that was no longer possible, because we would need to be really flexible and have, if a node falls down, we need to be able to reschedule on another one. We also exposed that problem to SRE, and they came back with using Ceph. For that, we're super happy. It was quite a challenge to set up, if I recall correctly, but now it runs super fine. Um, but yeah, those were the two main blockers we had to imagine a plan for that on the technical side. And once we really had that, we were able to make a plan on how to move from 50 instances of Jenkins at that point already uh, on one cluster and move them to another cluster and have no disruption to our users. And to share the knowledge of that, we decided at this point to onboard productivity and really plan the migration with them. So have them on board so that the knowledge of everything we were going to set up was also for them. And in this way, we were able to just remove the knowledge of all the legacy things or things we forgot in the old cluster as we were going to shut it down anyway. We were sure that everything that is on the new cluster are things that run today, that work today, and that they need to know as well.
As a team, you'd been working with Jenkins quite extensively for a fair amount of time. How does the new Jenkins, or also a new Jenkins on KubeVirt, all right? So new Jenkins on KubeVirt, how does that differ from the previous generation with what you were working before?
So from a user's perspective, it was mostly the same. There are a few things that change, but from a user's perspective, they still commit their code, get a build, and that works perfectly fine. The big improvements they saw, us and our users, is that there is proper build isolation because KubeVirt is a proper VM and it properly uses the limits that you set. Even if you have a Docker compose that's quite big, it will just respect the limits that you set because Kubernetes knows how to do that really well. And if you have one build that fails, you are sure at least that it does not fail because another build next to it used all the resources and just killed it. So that is one big advantage we saw with this new solution. We also made sure that for all the resources we have, again, memory CPU is handled, but for all the other resources that we have enough observability and enough information over how far we have from using them all. And we were even be able to just shut down our Sentinel because everything was now properly handled by Kubernetes. We had no need to have a second check to be sure that there is any dangling resources. To control also all this, we made sure that each Jenkins controller was on its own namespace. So that means that we can control the resources per namespace, being able to give a bit more to some or to constrain some if we see that they start to have a lot of big builds. And we kept our technique for caches, npm Maven caches that worked really well, and we kept that, improved it a bit even. And on the things that were more challenging is that the Jenkins Kubernetes plugin, well, it served really perfectly well for so many years. But the thing, it's primitive, is that it's starting pods, and KubeVirt is actually not a pod. So what we had to do is to trick it a bit and start a pod that would then run a bash script to start a VM and then shut it down once the pod is stopped. So this works fine, and we're happy with that. And the big trade-off, though, that we saw with this solution, but it's very manageable, is that, well, pods start instantly. Given that you have the Docker image on the cluster, it will start instantly, and your build will start very fast. But a VM, on the other hand, will take some time to boot. We did some optimizations, and we're happy that it's under 30 seconds. And for that, it works well. We had some comments, but in the end, we feel that it's not a big deal, because if your build is fast, well, under 5 minutes or something, if you had 30 seconds on that build, that's not too much. And if your build is already 30 minutes, well, 30 seconds is also not that much.
And in this case, why not use a micro VM?
We love the technology. We looked a bit into it. The thing was that at the time, apparently there were some kernel calls that were not working by using Kata, for example, that did just not do the trick. We're definitely we'll look into it again in the future. We see that, well, VMs starting in 2 seconds is very interesting, since it's the one challenge we have with the big VMs. But yeah, we might look into it in the future again.
So did the new cluster in Jenkins provide further room for optimizations?
Yeah, so one of the big advantages of having a cluster that is properly managed and has all the bells and whistles is that we also get Prometheus out of it for free. We were able to create quite a lot of dashboards out of the raw information we get from KubeVirt, from the cluster itself. So we have a dashboard for the general cluster health on from the KubeVirt perspective, how many VMs we have running at the time. We also went down a bit and have a cluster that is per team, where we can see how much resources they use historically or right now. And we are able, at the end of a build, we add a link to a dashboard that is specific to one build, and that was just so useful because we were able to know for a single build how much network it uses, how much IO, how much memory, how much CPU, and we even have some very basic calculation there that says, well, apparently you use not enough of your resources, so you could request a bit less resources. So we created a set of profiles like big, small, medium, large. And if you reach the limit of a smaller one, you can use a bigger one. But if you use one that is too big, you can go for a smaller one. This is very interesting for us because we believe that if you give some resources to a team, they should be able to control how much they use these resources. And they could either have a few very large builds or a lot of very small builds. And that is really up to them on how they optimize that. And we're really able to provide that to them out of the box.
Now, this was a pretty significant change, whether it's in a large organization or a small one. How did you keep teams invested in this? Because one thing can be the technical aspects, but people really have to believe, there has to be buy-in, there has to be commitment. How do you engage and persuade the business to respect this on the one hand, and then to, further to invest in it?
Yeah. So, well, on one aspect, you mentioned business. So that was not an issue for us to get them on board because we have a budget inside the department to take on these kind of technical projects. And so that was an easy sell for them to say, well, we are going to tackle this project and we will make it as transparent as possible. This is the other aspect for how we get teams engaged. We really try to make sure that it is for developers. So we try to make their lives easier, not ours. And we wanted to be very transparent on what they are going to win out of this, how we are going to make it, and how we are going to accompany them in the process. So we advertised the improvements that they would get out of it. We took really time to explain the different steps that we're going to take, when they were going to start, if they have a problem with that or a deadline or something, and they can absolutely not risk that their Jenkins might be down for an hour or so that we can migrate the data, that they can come to us and say, well, maybe just do that at another date. And we took the time to really do that with each team.
One thing, did you get any pushback though? Was there any resistance? Did you have to work around any of these? And if there was any pushback, how did you handle that?
Honestly, not a lot. On one aspect, our management was very supportive of this because we explained to them, well, we have this cluster that is now running for almost 10 years. Machines could break any day. That is a possibility. And if you had to take this machine, rebuild the cluster and make it work again, it could take like up to a week. We're no experts in that. It can happen. Or the other option is that we bite the bullet now and we do the migration to a proper cluster with the guarantees that it's going to be up and that we know how to rebuild them in case of huge failure, and that we are going to have some guarantees on the uptime of that. So they were really supportive of doing that migration, and for that they supported us also when we had to discuss with our team's management to say, well, we have to do it actually, and it's not against you, it's for you. And for every single thing, the one thing that was challenging is moving the builds from the Docker out of Docker to KubeVirt. All the other steps that we did in this migration, moving the actual controllers to the other cluster, was fairly transparent. Moving the data to Ceph, some well-placed rsyncs really helped there. That was really transparent. But moving the builds, we made a lot of tests first on our side. We onboarded some pioneering teams to be sure that it also works for their cases. We were able to do it build by build first. So we added a second cluster in the Jenkins configuration and said for each build on which cluster it has to be built. So they were able to just try the new cluster. If it works, they could stay there. If it doesn't, they can roll it back. It's a one-line configuration change. And for the ones that really did not build, we took the time. It was really less than 5% of our builds out of like 2,000 repositories, active repositories. Was really not a lot of builds that failed, but our productivity team did a tremendous job there. They monitored all the builds that succeeded before but failed after the migration, and checked one by one what they needed to fix there, what they needed to change either in the common libraries that we were using for tests or that was specific to their build.
Is there anything that you could have done differently?
Yeah, resource management. So the one thing that's we made a big mistake at thinking that it would just work out because it's Kubernetes is we really needed to think about every single resource and how it could fail. And that is something we did not do at the beginning because we did not think it was a thing. And the blast radius that we could get from one build exploding was huge. Today it's not the case anymore, but we should have thought of that in the very first step. So that's what I would do differently. And the other thing is managing our own cluster. So it's fun and all, but it's really not the thing we do best. And having alerts in the morning say, well, the node reboot did not go well. That's not the most happy we were. But now it's okay. It's handled in another cluster, and we know if it's a failure, the people who do that know exactly how to get it back up.
Now, after doing all this, what's next for you?
A lot of things. So on my side, not a lot of Kubernetes because our team will shut down its own cluster and benefit from the one that we have set up for us. As I said, my team is doing some architecture stuff. So we are going to start a project about the qualities and maturity of architecture for the teams to be able to assess their own architecture. We are putting the finishing touches on a project right now to update all our internal libraries to support Jakarta and be ready for Java 21. And yeah, that's what's on our plates right now. And on the SRE side, they are experimenting with some fun stuff. They are trying to use eBPF. Well, they are doing. It's in progress. They're using eBPF for automatic mock generation, being able to use the service mesh and everything to listen on that, and then maybe replace some of our sandboxes with that. And they're also, in general, experimenting with other eBPF solutions, for example, agentless observability. And on the productivity side, they are looking to how to maximize the Docker image cache hits.
What's the best way for people to get in touch with you?
I regularly checked my LinkedIn and Twitter, or X, if depends the name you use for that. Also, my email is fine. I do answer to that sometimes.
Okay, cool. Well, Stéphane, I really want to thank you for your time today. Appreciate you really going deep and explain all the things that went into this process. Your background as someone that doesn't come from this ecosystem, yet all the things that you've done, it's a substantial amount of knowledge, a lot of experience. I really want to thank you for sharing with us.
Thanks for having me.
Absolute pleasure.